In this video, we're going to introduce the ideas of precision and accuracy and how they link to error and uncertainty. Now again, these words precision and accuracy, you may have used these in everyday life, but they have a very specific meaning in physics. I suggest you pause the video and read the definitions of those two words in the context of physics. Now, accuracy here is a measure of how close the measured value is to the true value. So if we look at the set of data points on this dartboard here and this dartboard here, we would say they're both accurate. In both cases, if we averaged out the data, it would agree closely with the true value, which is represented by the center of the dartboard. Any individual data point, so any of these ones here or even over here, they might not lie at the true value due to random errors in the measurement process, but the data taken as a whole would produce an accurate result. Now, the combined data set of the points on this board here and this board here aren't accurate. The average value of the data set is offset from what the true value is due to some systematic shift, what we call a systematic error. Now, precision, on the other hand, affects how reproducible repeat measurements are. If you've got high precision measurements, it will produce data that's really tightly clustered around an average value, such as in this dartboard here and this dartboard here. As all these dartboards show, measurements that are accurate don't have to be precise, and precise measurements are not necessarily accurate. So for example, imagine you were measuring the height of someone with a ruler. You could take a whole lot of different readings or different measurements of the height, and they could all be reasonably consistent with each other, say to within a couple of millimeters. Now, we could say that they are pretty precise if they're consistent within 2 millimeters. But if all those measurements were taken with the same ruler that for some reason had 2 centimeters missing from the bottom of the ruler, you would say that the height measurement for that person would not be accurate. We would say it's inaccurate. Now, if there is one life lesson that you can learn by studying science, it is that nothing is perfect. If you and your measuring instruments were perfect, then repeat measurements would always be identical and would always give you the true value every time. But there is no such thing as perfect. Errors are unavoidable and there will always be uncertainty. Now, let's say we were taking some measurements. If we took a whole bunch of repeat readings of something, as shown by the X's that I'm drawing here on this graph, you would get what we call a normal distribution of values. So if you made a histogram of how many measurements there were of each value, then most of them would be clustered in the center, which is in the middle near the average value, which I'll draw in with a dotted line there. And there would be fewer of them as we moved further out there, out to the side, away from that average value. So the width of the curve tells us something about the precision of the individual measurements, so how tightly they're clustered together, how tightly they're clustered around the average value, and the position of the average value, which is the center of the curve relative to whatever the true value is a measure of the accuracy of those measurements. For this graph here, this one here, the curve of the measurements is quite broad, and so these measurements have relatively low precision. We say that they're imprecise. Now, the true value, which is that solid line there, is well within the central part of that curve. So we might say that these measurements are pretty accurate. They have high accuracy. Now for this other graph over here, the curve is pretty narrow. So all those measurements that may have taken, all those values that were measured are actually pretty tightly clustered around that average value there. And so we call that precise. But we would say that there is low accuracy, or that the measurements are inaccurate, because if we were able to compare it to the true value, which is here, so the measured value is over here, that true value lies well outside the main part of that curve there. So we would say that those values, those measurements were inaccurate. If you took some measurements and you happen to get the same value every time you repeated that measurement, so say instead of a broad distribution that all your measurements values were the same, and obviously that would be your average value, that does not mean you are perfect. Don't be fooled. It means that what you need to do is to find a more precise measuring instrument. So if you moved from a ruler that had centimeter divisions and then you got every single measurement exactly the same, what you would need to do is move to a ruler or a tape measure that had more precise divisions, so smaller divisions on there, and that would allow you to see what distribution of readings you would get for your particular experimental setup. So there we go. Precision and accuracy have very specific meanings in science, and you need to keep these in mind, and they will help you to interpret what's going on with your experimental results.